All right, this is a review of the last topics we covered in the lecture. Multi-select. What are good examples of coding client-side validation? Yeah, good. So client side means front end. So that's typically going to be things like HTML element attributes that are built in that the browser automatically knows how to provide some validation for, or things like front end frameworks like Angular that have their own validation tools that you can apply on the client side. Good. All right, Brad's in the lead. All right, put these in order. These should match the areas of an MVC app where different aspects of server-side validation take place, as you see in the image. What happens where? Yeah, okay, so this is good to review. So the very first thing that happens over in the model is that and I'll get that image back up here. Yeah. In the model, you define the rules and the error messages that then everything else can refer to. And then, these two things, enabling the validation and handling the validation, they both take place in the controller. The first one is done with that @valid annotation on the object. And then, yeah, thank you for enabling captions. I forgot about that. And then the second part, using the logic is where you actually check and see were there any errors in that errors object. And the last thing is to provide user with feedback and review. So good stuff. All right. True or false? A Spring Boot application automatically has validation built in and does not require a dependency. Yeah, that's false. It does require a dependency. It can be added when you create things ahead of time on the start.spring.io, or you can add it after the fact in the build.gradle file. All right. Which parameter is optional on all validation annotations, but it's highly recommended to always be used? Yeah, good job. Message. That way, if you define the message for that field in the model, every single field is able to have its own specific message automatically built in, and it gets passed through that errors object so that the page can, the view can actually display it with the field. Good. Which of the following annotations activates validation on fields and model? Yeah, so that's correct. Yeah, and I just realized that the question might have thrown you off. So you're activating it in the controller, but it's on the fields that are defined in the model. So I probably should have worded that a little more clearly, but you guys got it. You got it. The errors class provides an object that encapsulates errors and predefined messages when a model's rules are broken. That's true. I kind of gave that one to you already in my explanations, but I wrote this quiz like a week and a half ago, so sorry, I forgot. Okay, multi-select. Which are examples of providing a good user experience after input validation fails? I got some holdouts. 10 seconds. Okay. Yeah, so that's correct. You definitely don't want to reroute them to the next page. You want to send them back to the form. And you want to make sure those fields are still filled in and that there are very specific error messages on the field, which of course are the ones I just talked about that you predefine in the model. And you definitely don't want to send them to a white label error page. So that's where that activating the validation in the first place is important. No, activating it will send them to the white label page. Having the logic to handle it is what will prevent that from happening. Yeah. All right, Brad has got a strong lead. True or false? Passing an empty object to a template through a get handler makes sure input fields are already bound to model fields. True. We discussed this in lecture and, I gave you some examples and if you don't have any idea what I'm talking about, I would suggest you go back and watch that video again to make sure you thoroughly understand it because it is an excellent practice. All right, true or false? For proper data binding with validation, the th errors attribute should be given the value errors.fieldName. Yeah, that's kind of a tricky question. The syntax is correct, but the value would actually be something more like let's say the item that you passed in, you called it item. It would be item.field field name, because you give it the exact, you're basing it off of the model. So it's that object that's associated with the model, not off the errors object itself. But those are already tied together in a way, because the error messages and everything are defined in the model, they're already tied to the field. So you don't actually tap into the errors message for that, for the value. Yeah, a little tricky, but some of you got it. All right, which is true about an enum? Yeah, all of the above. It does contain a list of constants, and all values are static by default. So good. All right. True or false? Last question. To use an enum in another class, you must give the field that will store it in a string type. Yeah, that's actually false, because if you are using it at that point, you're giving it the type that is the name of the enum, right? Because that class becomes the type. So if you had, you know, I don't know, what was it? Oh, we had the example from lecture last time was style, right? We defined this enum named style. So in the class where you want to use it, like over in artwork, I actually created a field and I gave it the style type, because it's the enum itself that defines that type. So a little bit of a tricky question there. All right. Shrug is in third place. Maple's in second place, and Brad in first place. So Brad got a strong lead and kept it. All right. Good job, everybody. Close that and hand it over to Colin for a second.
Yeah, thanks, Carrie. So the only announcement I have today is we have one more speaker coming on Monday, and it's a very special occasion. So I hope to see as many people as I can there. This will be our last speaker for Unit 2, and maybe in terms of the whole semester. So I'm really looking forward to that, and you'll get some good insight into how to kind of carve your own path into the tech industry. And other than that, A4 will be going up shortly. So be able to start work on that in a little bit. And finally, oh yeah, I forgot to mention that it'll be 5:30 to 6:30 again on Monday, and then the rest of the time will be catch-up time. So be with the TAs, and there will be an attendance code on Monday. That's
Thanks, Colin. All right. I'm going to get screen back up here. There we go. All right. We are talking about SQL. So this is a little bit of a shift to kind of walk away for a minute from the Spring stuff and the Java stuff and just focus on SQL. What is it? How, you know, what's a syntax? How do you write it? How do you work with a database? So let's see. got announcements, lecture, and then studio. And as a reminder, this is the first class that we are trying out this new format where instead of me doing a review of studio at the very end of class, I'm just going to have it pre-recorded and post it for you guys. And I'm going to be straight up, I've been sick, so I haven't recorded it yet. So depending on whether I get that done by the end of class or not, it may or may not be up right after class. Otherwise, I'll just get it to you as soon as I can. Because tonight's one that I think you guys are definitely going to want to see the review. There's quite a lot going on. Okay, so yeah, catch-up class, as Colin said, is on Monday, and you will have the guest speakers and then split out into your groups. And then, of course, graded assignment 3 is due the following class, Thursday the 9th. That's in 1 week. Yeah, and I just said this. We are changing our format again. Changing it. So yeah, so reminder that you can use the lecture questions channel. Once you've had a chance to look at the video, if you've got questions, I am happy to answer them since we're not able to do it live. So just throw them in that lecture questions channel and I can try to get back to you as soon as I see it. Okay, so part 1 of the SQL curriculum is all about storing data in a database. So we'll talk about the concept of a relational database, talk about data types that are particular to SQL. And we'll talk about for like a second about the workbench tool that you use, the actual client you use on your computer. And then we'll go into at some length about writing queries to handle all of those CRUD operations, right? Creating and reading and updating and deleting. And then we're going to talk about joins, like what happens when you have more than 2 tables and you want to try to pull results from both of them. So that'll be it for tonight. And there's lots more to talk about in a week. Okay, so relational databases. A database provides persistent data storage for an application. That means that once you have that connected to your application, you no longer have to worry about every time you refresh your app or, and rebuild it and restart it, all of the, sample data that you had put in while you were testing it out is gone, right? And then you have to start all over again. You're not going to do that anymore because you're going to have a database that's going to hold that data for you. So again, this is the CRUD operations is where we are able to manipulate the data, create, read, update, and delete. So data is stored in tables, and every column represents a property, if you want to think of it that way, a property of an object. And every row represents an individual record. So, in this example, I've got, the three different types of artwork, right? And there's all the different columns that represent the different properties. And then there's each row is a different one of those artwork objects represented. And everyone should have an ID number. And we're going to kind of do it a couple different ways. First, we're going to manually do it and update it and feed it in as data as we create new records. But you can also have it automatically generated. And so I'm going to show you how to do that too. And then when we get back to working with Spring, we're going to use this tool called Hibernate that actually wires it all up magically. It's amazing. And the database will be automatically generating those IDs, and you'll no longer have to do it as part of your data. It just will happen. Boom. Yeah, and if you, every column and row has a value, but if you don't actually give it a value, it automatically just assigns it as null. It's just waiting for a value. It's empty. Okay, so here again, there's the table, there's the column, there's the row, and there's an ID number. And that's an example of a value. So when I'm talking about all of these things, this is kind of your reference for that. Okay, so data types in MySQL MySQL. So MySQL is a specific type of structured query language. That's what SQL stands for. And you'll notice that I may refer to SQL as SQL, and sometimes I refer to it as SQL. I do that interchangeably. Some people are very particular about which one they do, but it's okay. I think people pronounce it both ways. I apparently deep down have never made up my mind because I find myself pronouncing it both ways. What do you do? Okay, but there you go, SQL. So that's what it stands for. And this particular type, MySQL, has specific the specific syntax to cover the data types. So int is for integers, double for doubles. Varchar with the parameter max length is used for strings, and you have to provide it a max length and say, it can hold up to this many characters. And then Boolean, and there's kind of aliases for that, bool and tiny int. That basically just means it holds a 0 or it holds a 1, and that represents false or true, respectively. Okay, so in this example over here, I've kind of have taken that artwork object, right, and I've broken it out. So when you diagram a table, this is kind of how you do it. You just kind of list what are all the columns that this table is going to have, which is all the different properties of the object, and then what are the types. So I've kind of done that here. Okay. Oh yeah, the naming convention is to use snake case. You may have noticed that already. So that's lowercase and then use underscore where there would be a space. Snake case. Okay, so MySQL Workbench is a tool that you use to administer your database. There's a great whole section in your in the appendix of the SQL curriculum that walks you through installing and initializing a server on your local computer. And once you've done that, you can create as many databases as you want and work with them. And when we get back to working on the Spring projects, we'll show you how to connect them to your application. Okay, so the exercises that were in chapter 1.4 kind of walk you through creating a new schema. So I'm not going to spend a lot of time on that. I'm going to do it, but I'm not going to like really talk through it because I want to focus more on the syntax and writing the queries. That's what we're really going to focus on tonight. But as part of this process, when you use the little button here to create a new schema, it does actually generate a little script, a one-line script that just says create schema and gives it the name. And then it applies that, and now you are able to start adding tables to your database. So I'm going to go and demonstrate this for you. We're going to, I'm going to use this button right here. And oh, I forgot, I actually did have little, I have little things to call out what's going on here, and I forgot about it. Yeah, so there's the name of your server. That's the button that I'm going to be pressing here to add the schema, and this is where you give it a name, and it really is as simple as that. Okay, yeah, so I'm going to call this class 14 lecture examples. Is that what I did? I don't think I did the lecture examples. Yeah, you know what, I'm going to be consistent. If it'll let me be consistent. Okay. And apply that and say apply. All right, it was successful, a little green check. You're going to get to love the green checks and not be a fan of the red X's, but it's all a learning process. It's okay. Okay, so I got that. I can close this now. I don't really need to keep it open. But you're looking over here on the left and you're saying, okay, there it is. There's the class 14 example. So let's open this up and take a look. There's different kind of things you can look at here. We're really going to be focused on the tables, and right now there's nothing to look at, and if there was, you'd be able to kind of expand that, and then we'll have like more things we can kind of look at, but there's nothing there yet, so we're going to do that in a minute. So a couple things to note before we get started with that is if you have multiple schemas, you need to make sure you're applying your queries to the correct one, and the way to do that is to make sure that it's in bold. So you double click on the name, and then even if you have something else highlighted, the one that is in bold is the one that it's going to try to execute your queries on. So, over here, I can have nothing's in bold right now, right? But I can double click on this and you'll notice it's now in bold. I could come over here and highlight something else, but that one's still in bold. So as long as it's in bold, that's the one you're currently operating on. So just keep that in mind. And then the other thing is you can do comments in a script. You can do it with a hash symbol. Octothorpe is my favorite term for that. You can do it with double hyphens there, hyphens. And you just have to make sure, I think I have this on here. Yeah, you have to put a space after the double hyphens or it doesn't actually turn it into a comment. So keep that in mind. And you can also use the, slashes and stars, which is, common in JavaScript. It's common in Java and other things. I believe for some of my, for the examples I've got in front of me, I've used the octothorpe. Probably it would be better for you to use the double dashes. I think that's more common. So I probably will change it back to that before I commit the examples later for you guys to look at. But that's okay. So yeah, let's talk about creating a table. We're going to have a new script file. I'm going to use the create table command and give the table a name. And then you're going to have parentheses that you're going to kind of line out one by one. What are each of those column names that you've got? And what is that data type? So you remember I had that kind of little diagram. It's essentially kind of the code version of that diagram, right? You give it a name, you list out all the columns, you give them each a thing. And the ID, you're going to want to make that a primary key. And the reason for that is because there are certain things that it'll give you errors when it's in safe mode. Like for instance, if you try to update a value, if that particular field is what you are saying is how you're identifying it, and it hasn't been set as a primary key, it's not going to let you do it. So, and then there's other things that as we kind of unfold. In fact, I think in your studio tonight, yeah, there's actually, it talks about the primary key and foreign key concept, even though we're not really going to unpack that until the next class. You might get into it just a little bit with Studio, but they give you, references for it and everything to look at it. But yeah, it just basically says this is the main identifying field for this entire thing. So this is the column that it's going to use to kind of anchor what that particular record is, how it's identified. And later when we get to the relational idea of tables relating to other tables, that becomes really important. Okay, so they're separated by commas. You want to make sure the entire query ends with a semicolon. That's true for all queries that you do. And then the all caps that you see here for the commands, it's not required, but it is the professional standard, and you can actually even have it like beautify it for you and it'll, change it. I would say my recommendation is always just type it in that way to begin with. Just, be in the habit of writing good, clean, readable code always. So we write this, we execute it, and then we can refresh the schemas panel and we'll see that new table show up. It's not going to show up unless we refresh it. So let me get over to here. I need to move this a little bit over. Okay, so I've already created these files here, and they have our instructions to kind of walk us through this. But we can see here, the very first thing we're going to do is create this table. So I'm going to say create table. I'm going to give it the name artwork, and then I'm going to start these parentheses and just like that with a semicolon at the end. And now I'm going to name these things one by one. So we're going to start out with artwork underscore ID as an int, and I'm going to make it the primary key, and title, which is a varchar, and I'm just going to say, sure, 50, why not? And artist, also a varchar, also 50. That'd be a long name though. And then period. And I don't know, let's say 20. Okay. So those are, all the columns that we want to be able to have for this table. So I can go up here to the little lightning symbol, the very first one there, and hit go. And now if we come over here, we can, open this up and we see this tables, but we still don't see it. So right there, little teeny tiny icon is this refresh icon. So you click on that and it refreshes, and there's your table. So there's lots of things that you can kind of, look at here. For now, really the main thing that is handy is this little icon right here, where it automatically does a go get all of the records and let me see them. I just want to look at the whole table. So you click on this, it opens a new tab, and it gives you this little query, select, star, which means everything, from class 14 underscore examples dot artwork. That's the specific table we're looking at from this schema. So if we come down here and look at the results, it doesn't show much because there's not really anything to look at, right? We just have a bunch of nulls as the next possible record because there are no records. So that's okay. We're going to change that. All right. That was the first start. So there again, you've got the script file on the tab, and then that, yeah, primary key was already marked. Okay, so writing queries, adding rows with all of the values. So we can use this insert into command and make sure we say this is the table we want to insert it into. And then we give it a value, and this is basically creating a record. So every single one of the values for each of the columns needs to be put in there. And then you can make sure that the entire query ends with a semicolon. I've mentioned that before. I think this is like the last time I actually have it on the slide because it's just always going to be true. We're going to keep doing this. But when you have multiple queries in a single file, this separates them out to treat it as one. And then the next thing is you want to make sure you highlight only the query that you want to execute. We don't want to create the table again. So after we write this, when we go to run it, we're going to highlight it first and then execute it. And then we should be able to refresh our results and see that record. So let's add a record. We'll say insert into artwork. That's our table name. And then I'm just going to say values and say, let's do record 1. Remember, I mentioned that we're manually putting in our IDs right now. Leonardo da Vinci, and 1503 to 1506. Okay, so a single entry, we're just going to get that in there. So I'm going to highlight this row, or no, these 2 rows. I want to highlight that whole query, and then I'm going to hit this again. And it doesn't look like anything happens. But if we come over here to our artwork table, and I come down here, I can either rerun the query to just like completely rebuild it, or I can just hit this refresh button here. And there you can see the data that's been added. Artwork ID is 1, title is Mona Lisa, artist is Leonardo da Vinci, period is 1503 to 1506. So, it's a table. That's what it is. It's a table. Okay, so let's do a little bit more. We can actually have some partial values if we want to do this. And say insert into artwork, and then I can specify that it's going to be artwork ID, title, and artist, and maybe I don't know the period for this one. So then I might then say, okay, this is number 2. Let's do girl with a pearl earring by Johannes here, and that's it. And I don't actually give it that last one, but in order to do that, in order to leave them out, and it doesn't have to be the last one, it can be anywhere, you just specify which ones you're giving it, and then it lines them up, and you just do them in that order. So let's add this one in. I'm going to highlight it. I'm going to hit the thing there to do it. I'll come back over here and I'll refresh this, and there we go. 2, girl with a pearl earring, has Vermeer, and then null for period because we didn't give it anything. So it's just null. And as long as we're just like working directly in the database here, that's totally cool. Okay, so we could also add multiple records at a time. So let's do that. And this time, I'm going to do all of them. So I'm just going to say artwork and not specify any. The Starry Night by Vincent van Gogh, 1889. And then if you want to do multiple ones, you just put a comma and then start another set of parentheses. You only do the values keyword once. $1908. Okay. And then you end with the parentheses, and that's how you're able to add more than one at a time. So let's highlight these, run it, come over here, refresh, and there's the next 2, 3, and 4. Okay, anybody have any questions about this so far? This is pretty straightforward stuff. As long as you follow all the rules, it's good. Okay, so now we're going to talk about how to add a, we talked about how to add a row, how to add a record. Let's talk about adding a column. You actually want to make a structural change to your table and add a new column to represent a new property. So, I had another slide for this. Okay, sorry guys. Yeah, so this was just to kind of show you how you can specify the columns. All right, now adding a column. So we're going to use alter table. That's the command, and then specify the name. And then use add with the column name and the data type. And that will say, okay, we have a table that exists already. We just want to add one more column to it. And this is the name of that. And here is the data type, and that should do it. It's really that straightforward. So let's do it. Alter table. And we're altering artwork. And then I just can say add, and I'm going to add this on display Boolean to keep track of which of my artwork is actually out on display and which is not. So I can run it, got to highlight it, run it. And then we come over here. Now, if I hit refresh, nothing happens because this refresh button does not actually reflect the structural changes made to it. So I come up here and I actually say, okay, well, here's the query for this. I'm just going to run it from here. And it's unhappy. That's interesting. Why are you unhappy? Okay, let's come down to here and I'm just going to, yeah, and now it's happy. I don't know why I didn't like it, but it should have worked. But there we are, and we can see now that we have this new column on display, but of course it's null for all of them because we haven't actually provided values for those. So next we're going to talk about updating things and then we can take care of that. All right, let me make sure. Yeah, let's talk about updating. Okay, so to update a value for an existing record, the command is update, go figure. Specify the table name because that's the table you're operating on. When you have multiple tables, this part becomes important. That's why you always have to specify. And then set column, 1 equals value 1, et cetera, et cetera. You can do multiple ones. And then you can designate what those values are for those columns. But then you also have to have a condition so that you're specifying the record. This is really important because if you don't, you will be updating every single record with that value for that particular column. So just remember you have to set set that condition using where. Basically just says, go find just the record that has this, ID or whatever. And that's how I'm going to do it. I'm going to do it with an ID. So let's, because that's my primary key. Okay. So we're going to update the 4th record to indicate that it's on display. So I'm going to say update artwork table. So far we're just referring to the table. We have not referred to a specific record. That's the important part. And then set on display. And we're going to set that to be true. And then we'll say where artwork ID, ID equals 4. Okay, now I can do this. We'll run it as long as I don't have any mistakes. And I'll refresh this. And then we see it's 1. And you might say, okay, well, what if you did actually want to, set them all with some sort of default value so that at least they all have something? We could do that. We could actually just, take this part out and say, let me actually cut that. 0, let's, oh, hi. Okay, and run this. And it does, yeah, I'm in safe mode, so it doesn't like it. I would have to disable safe mode to actually, to get it to do that. So let's not do that example because I'm not gonna mess with that right now. We don't have time. Anyway, that's how I do that one. If I want to do additional ones, we can actually, like this one, we can go to the 2nd record to girl with a pearl earring, which, as you recall, we didn't give that one a period. Well, let's say we went and looked it up and now we're ready. And so we can give it a period. And then we'll also go ahead and set the on display while we're at it. So we'll do update artwork again, set, and then we can list two things. We can say, I want period is equal to 1665. Remember that that's a var or varchar, a string. On display equals 1 to reflect true for a Boolean. And then where artwork ID equals 2. Okay, because we want to operate on the second record there. So I'll run just this. And then we'll go take a look. Yeah, now 1665, and this one's indicating that it's on display as well. Okay. So now we're going to talk about viewing records, which is, you've already seen an example of how to do that because it's this, select query that's written up here. So let's take a look at this. We're going to do it a few different ways. So to read the entire table, that's the one you just saw, you can use the select command with that asterisk to read the whole thing. And if you want to just do certain columns, you could specify the columns. We'll have an example of that in a second. For the from keyword is where you specify the table name. And then you can just run it and then this grid pops up below. So right now we've been flipping over to this other tab because I ran this thing separately using this little icon over here. But we could actually just show it right below here if we run it right here. So let's do that. Select, and I'll just start by saying I want to all records from artwork. That it's that simple. And I'm going to select that line and run it. And there it is. It's right here. And we can see everything. So now let's go and say, what if we wanted to view only the artwork that was currently on display that has, a 1 in this column? That would mean we want to read, do some filtered results. So we need a little more syntax, right? So we'll use the select command, use that from keyword again with the table name. And then we'll add a condition to actually say, where, some column equals some value so that we can find, which ones of them we want to view. And it'll filter out anything that doesn't meet that condition. So you can have multiple conditions. We'll do an example of that as well. And you can use those logical operators and or not. There's actually quite a lot of them in documentation if you want to look it up. You can get pretty fancy with it. And then same thing, we'll execute it, highlight it, execute it, and view the results. So let's do just the stuff that's on display. So I'm going to say select, and we'll go ahead and look at everything. But we'll specify that we only, and everything, I mean all of the columns. So the asterisk represents all the columns. And then to specify which records we want, I'll say where on display, that was the one we specified, right? Yeah, equals 1. And run just this, and then we'll get only the ones that are on display. There we go. So we get records 2 and 4, and that's right. Those are the ones that we actually specified were on display. Okay. And then in order to actually view, make this a little bit more complex, I'm going to add some more records, and I'm just going to copy and paste it. So I'm going to write another insert here and say, I want all of these values, multiple records for more of these artworks to be added in. So let's go run it. And once I've done that, let me get this out of the way so we have a little bit more. Okay, once I've done that, I'm going to come back up here to my just show me everything, and you can see it. Yeah, so now we've got all the rest of these. And I went ahead and gave the values of 0 for all of these for those. That's fine. So now we can actually say, okay, let's go find all of the artwork that's by Van Gogh. But we only want to look at titles, artists, and periods. We don't want all columns. And which, basically means the only things we're not going to be looking at is artwork ID and on display, right? So let's write this. We'll say select, And then we'll say title, artist, period, from artwork. And then where artist equals Vincent van Gogh. As long as they are all exactly the same, it will correctly do this. And this is where that concept of having validation, having enums to control like fixed values for things, this is where this really matters, right? Because we want to make sure that every single record has it exactly the same. It's not misspelled. Like, what if some of them had a capital V in the, here, this was all run together with no space. Now we're not going to get the complete results. So if we are handling some things in our application that will validate and prevent these kinds of things from happening, then the database is going to be able to do its job and find everything that is by Vincent van Gogh without fail. So when we get back to using this with an application, you'll kind of see how that works. So now we get the results. Title, artist, and period are the only columns that we see. And we see all 4 of these by Van Gogh, but we don't see any of the artworks by any of the other artists because we filtered those out. So those are some good examples. We can actually, do this again and say, what if we have multiple conditions and we want to do something that is have a little bit of logic here. I can actually put this in parentheses and then say and then say period equals, that's a string, 1889. So now let's run this one. And we should see this filter down even more, except for it looks like I made a mistake. Oh, I forgot my closing parentheses. There we go. Yeah. There's that little red X I was talking about, guys. You're going to see lots of that. It happens. And now, yes, it's filtered down. And now we're seeing not all 4, but just those 2 because it filtered on both of these columns. Okay. Does anybody have any questions about that before we move on? I think I've got one more we're going to do here. Mina, you got a question?
Yes, Carrie. Actually, you made the integer as auto increment, right? Primary key.
I did not. I did not. No, not this time. I'm going to do it in my other table.
Oh,
so
okay.
I've been manually adding those because I did not set it for auto increment. Not yet.
Okay. Thank you.
Yeah, when we get to talking about joins, I'm going to talk about that a little bit, and I'll show you guys what that looks like.
Okay.
Okay, so let's do one more select here, and this time I'm going to select the title and the artist only, and I'm going to say from artwork from the table, and then where, and this time I'm going to say if artist equals Leonardo da Vinci, or artist equals, so it's the same column, but I have 2 different people that I'm looking for. So there's lots of different ways that you can do this. And this time it's going to go find it if one of those 2 things is true, because I used or. All right. Yeah. So now we get all of the artworks that are by one of the 2. And I have, 2 of each. So, okay. Last thing is, I can't remember if I actually put this in the slides. Yes, I did. Okay, good. So if you want to order your results, you can actually, set up your thing select, but then you can say order by, specify the column name. And then if you want to, you can add on to that and say ascending or descending with ASC or DESC. So let's do this exact, we're just going to do all records. There we go. Okay, so select all, so that asterisk from artwork. And you may have noticed that sometimes I have this on the same line and sometimes I don't. It doesn't matter. As long as it's all before this semicolon, it's all actually one big query. We just break it up for readability. But for something like this, it's not a big deal. Then I'm going to say order by. And what did we say we're going to do? Period. Yes. So order by period. And I'm going to say ASC for ascending, and then end my query. And I'm going to select it and run it. Okay, so now you can see the artwork IDs are all out of order, right? because over here it's gone to the period and said, let's put all of these in order, ascending. So we go back to 1498 all the way to 1908. All right. The last little bit to talk about here is deleting. So to delete a record from the table, we can actually just use the delete from command and then just give the table name and then some sort of condition to say, here's how I am identifying what it is I'm going to delete. And, a common one to use would be the ID. That's, because that's usually your key for identifying something without having to worry about duplicates in any of the other columns. So let's do this as an example. We will delete the bedroom record. So if we come down here and find the bedroom, we can see that that's actually ID number 7. So that's what we're going to use to delete it. Oops, delete from artwork. So we name the table first, and then where artwork ID equals 7. So now go find the specific record in the artwork table and delete it. So I'll run this. And now if I come back up here and do one of my select things to read it, we can see now, yeah, and this actually would be easier to read if I go over and do this one. So let me do this one. There we go. Yeah, because you can see it's 1 through 6, and there's no 7, and then we have 8 and 9. So it deleted it. All right. So that's pretty much it for how to write all these different kinds of queries. There is certainly tons more syntax to learn. We'll be unpacking a little bit more here and there. You'll kind of dig into some things in Studio, and then when we do part 2 a week from now, we'll talk about some other things too. But this is the basics for CRUD operations. Okay. So now let's talk about joins. The idea here is that you have 2 different tables and you want to actually maybe see what they have in common, or display information from one table, but in the context of something else with some information from the other table. Or maybe you just want to see all the information from both tables all in one result. So this is kind of how we do this. So an inner join is where you have only the things that they have exactly in common. A left outer join is everything from the first table, the left table, plus the things they have in common, but excluding anything that they don't. This is the opposite. You want to make sure that it's basing it on everything that's in the right table, the second table, but displaying the things that they have in common. And then this is where it just goes and gets everything, whether they have things in common or not. And you still have to specify kind of how do the 2 tables relate? So you have to have at least one column on which they can relate. So what we're going to do is we're going to, before we actually start getting into the joins themselves, we're going to set up a second table, and then we'll start, doing one of each of these so you can kind of see how they work. So I'm going to switch over to here. We're going to create a new table called artist. And we're going to give the artist its own ID and have that artist name. That name field is what will actually relate to the other table. And then a style, as you remember, in one of the recent classes, one of the things we were doing was adding what are the different styles of art that these artists, are producing. So we can kind of find a way to relate that now by relating style to the artist, and then seeing what artworks that share that artist then, relate to that style. This is how we're going to do it. So we're also going to add auto increment so that we no longer have to manually provide those IDs. So let's do it. We're going to create a table, and I'm going to call it artist. A little word about the choice to use this as singular rather than plural, because some of your examples in your textbook might have it in plural, and that's okay for now, because you're representing a table of multiple artists, right? You could be, or multiple artworks, so you can think of it that way. When we get to the point that we're relating it to your application, your tables are generally going to be based on your models. And so it's going to be singular. So I'm going ahead and I'm naming it singular just because that's where I'm headed ultimately, and I want to be consistent. But if it's okay to use it either way while we're just working in, in the database. So just that was just something I wanted to mention about that. Okay, so artist ID. And then we're going to make this an int, and we're going to make it the primary key. And then we're also going to say we want this to be auto incremented. So we add all of those extra little keywords on there, and that'll take care of it. Now, full name, and this is going to match what the artist name is on the artwork table. So I'm giving it a varchar of 50, max length of 50. And then style, we'll say, is a varchar with a max length of, I don't know, 25. Probably unnecessary, but there it is. Okay, so let's create the table. All right, so we've created the table. And if we come over here to our tables, we still only see artwork. We're going to come up here and refresh this list. And now we can see that we have both tables. So I can come to this artist table now and click on this and go ahead and get this on another tab. And we can see we've got artist ID, full name, and style columns, but we don't have any rows yet because we haven't added anything. So let's go ahead and do that. I'm going to copy these in just to save a little time. All right, so insert into table. The table name is artist. And I'm specifying full name and style because I have an auto incrementing ID. I can no longer get away with not having this and just saying artist, because I've got that auto incrementing ID. I don't want to have to provide it. I want, MySQL to provide it. So I just list the columns that I am providing to make sure they line up. So I'm giving the values of the name and the style for each one of these. And I've added Van Gogh, Da Vinci, and Vermeer. You'll notice I did not add Gustav Klimt, even though he does have a piece of artwork in the other table, but I did add Monet, and he does not have any artwork in the other table. So I'm doing that on purpose so we can kind of see how, some of these tables might have similarities, they might have differences, sometimes they have things in common, sometimes they don't, and that's going to help illustrate how these different things work. Okay, so now let's talk about these joins. We've got these two tables, artwork with a bunch of different art by different artists and different periods, whether or not they're on display. And I haven't actually executed this yet, have I? Ha ha ha. Let's execute that and actually get them in there. And then there we go. All right. So now we can see our records. So we've got, I can see it automatically assigned 1, 2, 3, and 4. Okay, so no, back here. All right, let's go to the slides. So let's talk about the inner join first, where they have two things that are in common. We want to use the select command with certain columns, and then use the from keyword and specify whatever the left table name is, the table that you want to kind of be your default table. That's the one you kind of consider to be your left table. And then you're going to use inner join, and you'll designate what the right table is, the secondary table. So again, from the left table, inner join the right table. I think the thing that I got confused about the most when I was learning this as a student was, which one do I put where? Does it matter? And it does sometimes. It depends on what you're looking for. If you're just going to select all, it kind of doesn't matter. But if you're going to select certain fields, it can matter. But that's it. And then you just say on to say what are the columns that they have in common. And you'll remember that I said that for our artist, it's the artist column of the artwork table and the full name column of the artist table. So I use dot notation here to connect them, to make sure that they are. I cannot. There's a word that's escaping me. But anyway, that's how you say I want you to go. Kind of find all the artists that match on this, and just see. What do we have in common? What do these two tables have in common? So we could do that. And then I got, this little note here, you can eliminate duplicate results by using this distinct keyword right after select before you give whatever it is that you're looking for. And in this case, I want to just look for the artist. And so when I talk about, does it matter which one of these is kind of your left table versus your right table? This is where it matters. If you only want to have like one field, then you have to name the table. You have to use the name of the field that belongs to that table. These have to, one has to be a part of the other. And then the second one can be the other table. And I realize this might be a little bit confusing because I have a column in the artwork table that's called artist, and I have a table called artist. But that's what's going on here. I want the column from artist from the artwork table to be joined with the artist table on those fields where the full name of the artist table matches the artist name of the artwork table. Okay, so let's write that here. Select artist from artwork. So we know artwork has an artist column, so we're good there. And then we do the actual join part, inner join. And this is where I choose the other table. So I'm going to say the artist table on, and I'm going to say artwork.artist equals artist table dot full name. Because that's the column of that table I want to match. Okay, so let's see what results we get when we run this. Okay, so you can see that I've got Da Vinci, Vermeer, Van Gogh, Van Gogh, Van Gogh, Vermeer, and Da Vinci. I have multiple records that these two tables have in common. So what's missing? Well, we don't have Monet from the artist table because he doesn't exist in the left table. And we don't have Klimt from the left table because he doesn't exist in the right table. We only have the ones that are in common. But you remember I said that we could, get rid of these duplications because maybe we just want a list of them without all those duplications. We can put distinct right here and run this, and it will clean that up for us and take out those duplications. There we go. So really, it's just Da Vinci, Vermeer, and Van Gogh. Those are the three artists that the two tables have in common. Okay, so now we're going to talk about the left join. What happens when you want to see the results from the left with a bunch of columns from there, but again, checking to see what's in common with the stuff on the right. So anytime you are going to grab columns that you want to be displayed that are from both tables, you have to specify which table they're from, and you can use dot notation for that. And then it's after that, it's the same. You say, from the left table name, and then you use left join instead of inner join, and then right table name and on, and then you say, what's the column that those two, have matching values for. And that's how we're going to pull the information. So to do this, we are going to go get the titles and artists, and also, so titles and artists are columns that exist on the artwork table. Style is a column that exists on the artist table. So we're going to combine columns from two different tables so that we can see those results displayed together. And then we're going to make sure that it's on the basis of all of the ones that have the artists in common. So select, and I'm going to go ahead and keep using distinct here. Although that doesn't actually matter as much, because if we're throwing the title and everything in the works, it shouldn't matter, because they're all going to be those. We know for sure those are all going to be unique. Okay, so here's where I have to specify which table each of these columns is connected to, because these two are part of artwork and this one is part of artist. So you just do that with that dot notation there. And then say what your left table is. The left table is artwork, and the left join, sorry, is going to be artist. That's a secondary table from the right. And then these are the things they have in common. This part is the same. Artwork.artist equals artist.fullname. So again, if you want it to be a left join, this you have to, make, if you want artwork to be the left, then you have to make sure that's the one that's on the left. So let me grab this and run it. Okay. So what you see here are all the ones they have in common, right? With the styles, but then you also see one that they don't have in common, still included because this is a left outer join. So it still includes things from the left table that may not have actually matched anything on the right. That's the difference between just doing an inner join and doing a left outer join. You're still going to have some results that may not have values from the other column. But we can do a similar thing with right outer join to do it kind of the opposite way. And so instead of Klimt, we expect to see Monet in the results, right? So it's exact same setup. It's just that you use right join instead of left join as the command here. So I'm gonna literally copy this and just change this to right, because that's the only thing that's different about it, but the results will be different. Okay, so you can see we've got all the ones they have in common, plus we have impressionism, which is a value from the right side because that's the only thing that we said we wanted to list was title and artist from the left and style from the right. So we have impressionism. We don't know where that came from. We know because we've seen all the data that it comes from that from Monet, right? But we didn't ask for the full name field. Now, if we wanted to do that, we could say, add full name and style. And we could add that here. Artist dot full name, and then we'd have a little bit more information to help understand, where that's coming from. But let's run it again. Yeah, and so now you can at least kind of see, there was a different artist name there, but the reason these are null is because we didn't have any artworks by that artist. This is coming only from that right column, or I'm sorry, from the columns from the right table. Yes, and these are the columns from the left table. Does that make sense? Does anybody have any questions about this? It can be a little hard to wrap your head around at first. Okay, so that's that. Everything in the right table with, the basis being what they have in common. Okay, so the last one is the full outer join. So this is where you just want to see everything. And you can, decide which columns you want to actually see in the results, but it's going to give you everything regardless. But you do still have to say kind of how, how do they relate? So you just, this is, this slide is, sorry, the slide is apparently incomplete. So sorry about that. I'll fix the slide. You actually can't use, there's no, in SQL, there is such thing as a full join. But MySQL specifically, that version of SQL doesn't have that syntax. So what we do instead is we use a union. And we actually are going to set this up where we basically do two different joins and then do the union of them. So yeah, apologize about the slide. I'll fix that. I didn't realize I hadn't edited it. So what I'm going to do is I'm going to have a join that I do that's a left join and a right join, left join on the left table, and then a right join. And then I'm just going to do it all in one line and make it really, really simple and just say, we're just going to look at all the columns and we'll see everything all in one place. So we'll do select all from artwork. That's going to be our, left table, and do a left join. On artist, the secondary table on the right, and then choose that same basis of the things that match are that the artist from the artwork table is going to correlate. That's the word I was looking for earlier. Correlate to the full name column of the right table. Okay, so that's the first one, and then I'm going to say union. and then I'm going to give the second one. So you're essentially doing two different selects, two different sets of results, and then it's going to find the union of them where it says, okay, just put it all together. But here I need, in order to do all the stuff on the right, I need to make that a right join. Okay, so left join, right join, union. That's the deal. Let's run it. Okay, and we now see everything. And you'll notice that they're not in order by artwork or excuse me, artwork ID. They're in order on the basis of it having matched up the artist's name and the full name. So it found all the Van Gogh, it found all the Da Vinci, then it found all the Vermeer, then it found Klimt, which was only on the left side, and then it had Monet that was only on the right side. But we're seeing everything all in one place. And anywhere that there was not a correlation between the two, we just have null values for those. Okay, how are you guys feeling about this? Any questions? I know we ran through a lot. Practice is key on this. The more you practice this, the easier it comes to you. And you're going to make mistakes and you're going to get those red X's and you're going to learn from that, I promise. Nathan?
Yeah, I was wondering if you could just offer any more insight into unions behavior. I mean, since it's not, I was just thinking it is it's not giving you like duplicate entries that were found
Right.
with both. So is it
yeah, it's basically,
yeah, I was just wondering if you could offer any more insight into how that actually is it similar to a sorry, I already lost the term, a inner join effectively?
well, no,
Or no, because it's getting both, but it's
yeah, so it uses, like, in other words, the left join gets everything that's on this side, right? Let's go back to this slide, talk about all of them all at once. Okay. Left join gets everything that's in the left column on the basis of what they have in common. Right join gets everything in the right column on the basis of what they have in common. Inner join excludes anything they don't have in common at all. So you don't get anything associated with Monet on the right. You don't get anything associated with Klimt on the left. Full outer join is just everything. So what essentially it's doing is taking these two, combining them together, and it's like it's got distinct automatically built in. So that if there are any duplicate results that represent this overlap right here from these two, it only presents them one time.
that makes sense. Thank you. Distinct is what I was trying to ask there.
Yeah, that's the key word. Yeah.
Cool.
So if you're only doing, if you're doing one of these, you're going to want to use distinct for in case there are, it kind of depends on what columns you're doing too. Because if you have enough columns that they're all going to be distinct, especially if you include an ID, distinct doesn't really matter anymore. But in the case of that very first example we did where we were just doing the artist, that actually became important because when I ran this one, then we just got multiples of some of these artists because that was the only column we were looking at. Yeah. Okay. Any other questions? Flip forward to here. There we go. Okay, so for tonight's studio, you are going to create a new schema called Movie Buff. You're going to create two tables, movies and directors. You're going to learn how to import data from an external file to automatically populate tables so that you don't have to write, like line by line, here are the values for this record, here are the values for that record. You'll be able to automate that. And then you may learn a few other new things as well. So you can come over here. They kind of give you a walkthrough of the setup for everything, getting everything in place, creating the movie table, and it kind of gives you, what talks about what columns you need, the director's table, what columns you need, how to relate the tables. And then it's going to, say, we actually need to, correlate some things. We want to do this auto increment thing. So it's going to teach you how to drop a table. That's not something that I actually demonstrated for you. I certainly didn't demonstrate it as a command in the script, but there's actually another way to do it. If you are working on something and you get there to a point where you're just like, and you're still just kind of in God mode, right? You're just designing it. So you're not breaking somebody's data, because you have to be careful. You don't want to drop something. If there's data in there that somebody put in through an application and some other mechanism, and there is no way of retrieving that once it's gone, right? So this is something you typically are only doing when you're kind of in development mode, but you can actually come over and right click on this and say drop table, and it'll drop the whole thing. And so like right now, if I, the artist table no longer exists, but I can come back over here and run this entire script from top to bottom to have it, take care of everything. And then we see, that we've got those results at the end, and I can come back over here and refresh this, and there it is again. And I can, pull that out if I want to and see what it is, but yeah. So that's another way to drop tables, just so you know. But they're going to have you actually do it as part of your script, so that you kind of have things going together. And they're going to talk about this foreign key concept of relating one table to another on a specific basis. So there's some cool stuff in here to learn how to insert a data from a file, things that they intentionally kind of leave out initially because it's too much to cover in a lecture. But it's also something, and they can walk you through it, and you can learn how to do it as part of your studio. So it's going to be a fun way to learn a few more steps and also practice all the things that you did in the exercises, all the things that I just talked about. And if you have time, you can do the bonus missions. So I will get that video up to you as soon as I can. But you guys have a great studio. And also have a great time with the panel on what day is it? Oh, Monday. On Monday. And good luck finishing up your graded assignment 3 for those of you who are still working on that. And I will see you next Thursday for MySQL Part 2.
Thanks, Carrie.
Have a good night.
Thanks, Gary.
Thank you.
Thank you.